This video is going to talk through the first problem from our CYU on covariation, where we're looking at a runner going around a track. Now in this particular video, I'm not going to sort of re-type up the answers that you can, that you can sort of see for part B. I am going to talk through sort of where that thinking comes from, but the focus is going to be more on how do I get from this situation to the graph and to that description, and helping you better sort of get into that sort of mindset. So in this particular problem, we are looking at a runner going around a track. And I know it says a quarter-mile track, but as a ex-track runner, I can't think of it as a quarter mile. I think of it as a 400-meter track. And so in my mind, tracks are split up into 100-meter segments, and that's just how it is. So that's where my brain's going to go. If you want to think about it in terms of miles, that's fine. But just so you know, in this video, even though I know it says quarter mile there, I'm going to think of it in terms of meters. So it's a 400-meter track. So we're just going to put a little note there so you know where I'm coming from. And we have a radar gun sort of from the start line that is tracking the direct distance of the runner from that point. Now, as you move around the track, you're actually, like, let's imagine this runner has, one of our GPS smartwatches on. The runner is tracking the distance they traveled. And so we sort of have two different distances in this case. Now, you might be going, okay, but how fast is the runner moving? Are they running at a constant speed? Well, I'm going to let you in on a secret. That doesn't matter in this problem. Speed in our sort of construct of our mind is, a distance per single unit of time, feet per second, meters per second, miles per hour. That doesn't matter here because we're tracking distance per distance. So we're looking at the relationship between the runner's sort of distance from that start line as a function of how far they've traveled. And so when we're doing this, since we're making this sort of, the distance the runner has traveled around the track, I like to always think, whatever this sort of independent, variable is, that's sort of what I want to break up into equal sized pieces. And when I get those equal sized pieces, I can then sort of think about how the other variable is changing as that distance increases by equal amounts. So I'm going to start with the easiest way to split it up is we could sort of, you got the end of this straightaway. That's 50 meters. Okay. And then, the end over here, the end of the curve would be, that's 100 meters later, here's another 100, here's another 100, and then 50 back to the start. Now I went 50 in this first chunk, and we want to split this into equal chunks. So, I could sort of go in here, and then I got a bunch of 50-meter chunks. And that would give me an okay glimpse. But if I want to get, sort of a little more details in what's going on in the in-between, maybe I want to split it up into 25-meter chunks. And so what I've done here is I'm just sort of thinking, okay, well, halfway between those two is going to be where my 25 meters hits. And on the circles, it's not perfect, but it's going to get you a general idea. And so what I've done here is I've sort of divided up my track into chunks. So it's like, okay, the runner ran 25 meters. What's happening to that distance from the start in those 25 meters? So, I could think of this, I'm going to think of this as point A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. And the reason I gave these all letters is I'm going to then relate these positions on the track to places on my graph and talk about how the quantities are changing in between these. So initially, we're on a straightaway. And so I find it helpful to actually make little sort of segments here so you can sort of see what's happening. If you think about this first going from the start line to point A, the runner traveled 25 meters. The distance from the start also increased 25 meters. And then if I think about the next sort of chunk, the runner ran another 25 meters. And the total distance traveled is now 50, which means we increased by 25 meters, the same distance, you know, that my distance from the start increased. So that's why you'll see in this description, on that first straightaway, the distance run is equal to the distance from the start. They're both increasing together by the same amounts. And so if we sort of go down to this graph here, you know, we could think of this as sort of, you know, this is sort of our first, you know, bit of this graph, you know, from here to here, you know, we're now at, oops, I probably went a little too high there, sorry. Because I would, you know, this is our max. So we'll talk about where that point is in a little bit. But I bet probably about, I know, now I'm having doubts of my little like, okay, so like we'll say that's about, this is our sort of 50 meter mark, and so this is 25. And if you notice over here, you know, sometimes I like to draw in little slope triangles. You know, yes, we increased 25, and this sort of amount that went up each time should be about the same. So this sort of change in distance from the start line stayed sort of about the same for those first sort of equal changes in distance. But then we hit the curve. And if we take a look at the curve, notice, and I'm going to sort of clear out, oops, some of these other lines. Delete, delete. You'll notice now, so if I compare, oops, I draw sort of point to point C, oops, I should have left the one in there to point B. And then to point D there. My distance from the start is still getting bigger, but now it's not going to match exactly the distance that the runner ran. And if you notice here, each of these times, that distance is going up by a little less because of the curve. So, you know, initially, yes, my distance from the start is increasing, but it's not increasing the full 25 meters anymore. And then this one's increasing even less. You can sort of look, you know, at that sort of change here. It's not quite as big as it was like over here. So it's starting to increase, but by less and less each time. And so, you know, yes, the distance the runner is running is still 50 meters, but now the distance from the start is going to be increasing by a little less for each of those 25 meter intervals. So, you know, that distance increased here is smaller and smaller till we hit this point D here. And why point D is important, and we're going to put point D over here, is D is one of those points where we're the furthest away from that start line. And as we sort of come back around the curve here on the other end, our distance from the start is actually going to get closer and closer again, but not quite as close as we were over at point B. And then we'll hit the straightaway, and we'll sort of keep getting closer and closer to that start line as we sort of work our way around. And what I actually like to do is sort of watch here. You know, yes, this line is now getting shorter and sort of shorter until we hit this point H. And point H is important because that's sort of the point midway through. Oops, didn't want to do that. Let me delete that. Where we're the closest we are to the start line as we until we sort of come back around to our home stretch. And then we sort of can keep working our way sort of around, and now we're getting further and sort of further away again from our start line until we hit point L over here. And at point L, we're again at that sort of max distance away from the start line. And then, you know, oops, come back here. So L, we're at our max distance, and now we're getting closer and closer and closer. And as we come back to the straightaway where we're now traveling, you know, the distance we travel around the track is equal to the changes in distance from the start until we're back at the start line, where we've traveled now a full 400 meters. So, you know, this over here would be 400 meters, but we're 0 meters from the start. And so this would be, you know, back at the start line. So a strategy when approaching this is to sort of, you know, break your sort of diagram of the situation up into pieces and really think about what's going, you know, I sort of split it up into equal pieces of distances that the runners travel around the track, and then sort of, you know, drew in these segments to help me visualize that distance from the start line. And then use that. Now, keep in mind your graph might look slightly different from this. You know, you might have made some things a little more linear than this one is, and that's okay. You know, this is a sketch. Notice that there are no real numbers put on either of the axes, and that's because it's a sketch. You don't need exact distances with this. This is just to get you sort of thinking about those changes. And so as we're sort of talking about those distances becoming, you know, increasing by more and more, or they're decreasing by, you know, more and more, sort of those, or decreasing by less and less, you know, those sorts of relationships. Hopefully this video gives you sort of a starting off point for how you could approach and think about this question. Definitely go back and check out those detailed solutions and sort of read through those answers if you want sort of a more detailed answer than what you might find in this video.